newly discovered asteroid is racing towards Earth. This time, it's not Apophis, who has kept us in suspense for years. The latest update from NASA reveals the truth about asteroid 2024 YR4. Discovered in 2024, this asteroid is the first in the history of modern astronomy to have had its impact probability revised upwards twice. This could mean that we will soon have to resort to an active asteroid defense measure for the first time. The current asteroid 2024 YR4 is comparatively small. With an estimated 50 to 100 meters, it remains in a range that does not pose a global threat. However, the size is sufficient to devastate an entire region and several thousand square kilometers of land. What is unusual about this asteroid is not the size. It is the probability of impact, which has now risen from 1.6 to 3.1% for the first time. For the first time in the history of asteroid observation, NASA has had to significantly revise the danger upwards. With the asteroid Apophis, discovered in 2004, it was the other way around. After an initial warning and an impact probability of 3%, the danger became less and less. In the end, NASA corrected the risk to almost zero. So, we have survived Apophis, but now 2024 YR4 is heating up tempers. The small asteroid could hit the Earth as early as 2032, somewhere in the Pacific region, South Asia, the Atlantic, Africa, or Arabia. What would happen then? Will YR4 burn up in the atmosphere in 2024? Experts are unsure. Will the newly discovered asteroid really hit the Earth's surface in the event of an impact, or would it burn up in the atmosphere? Both are possible. YR4 is on the borderline in terms of size. It could detonate just before reaching the Earth's surface, like the Chelyabinsk asteroid. In 2013, the asteroid took the residents of the Russian city by surprise. All the people heard was a deafening boom, and then the shockwave shattered the windows of numerous houses. Some of the people curiously standing at the windows suffered severe lacerations. The Chelyabinsk asteroid was probably a bit smaller than 2024 YR4. Nevertheless, the devastation it caused was remarkable. Imagine, the detonation released the energy of 30 Hiroshima bombs in a matter of seconds, and this asteroid was comparatively tiny. If YR4 were to impact the Earth's surface, it would easily destroy an area of several thousand square kilometers. The immediate shockwave would be strong enough to wipe out entire neighborhoods, collapse buildings like houses of cards, and kill any unprotected people in the vicinity. In a metropolis like New York or Beijing, the explosion would not only cause massive destruction, but also trigger fires that would spread even further due to the debris that had been blown up into the air. The detonation could cause an enormous heat wave that would incinerate everything in a wide radius. The shock wave would be so strong that it could damage windows and houses hundreds of kilometers away. If YR4 were to impact in the ocean, the threat would be no less frightening. Such an impact would trigger a gigantic water displacement, which could lead to a tsunami of apocalyptic proportions. Depending on the asteroid's impact velocity and angle, the waves could reach heights of over 100 meters, far higher than the tsunami waves of the horror tsunami of Christmas 2004, which killed over 230,000 people. Coastal cities could be wiped off the map. Millions of people would have to be evacuated, and the water masses could penetrate deep inland, destroying vital infrastructure. But it's not just the direct destruction that's a problem. Such an impact could hurl so much dust and soot into the atmosphere that seasonal climate changes and crop failures would be likely. The exact consequences of an impact are difficult to predict, but one thing is certain. If YR4 were to hit land or water, the effects would be catastrophic and could endanger millions of lives. If it turns out that YR4 will hit Earth in 2024, we would certainly resort to asteroid defense for the first time. The deadline is December 22nd, 2032. 3.1% on the Turin scale. That's a record. Despite the danger, experts warn against a hasty panic. The record value of 3.1% on the Turin scale could also fall again. The Turin scale is a system for evaluating the danger posed by near-Earth asteroids and comets that could collide with Earth. It ranges from 0 to 10 and takes into account the probability of impact and the potential damage. Should the value continue to rise contrary to these forecasts, the international community would certainly make plans for an effective defense. Just letting YR4 crash into Earth would be pure madness, especially since we already have a functioning asteroid defense. In 2022, NASA proved with the DART mission that it is indeed capable of significantly pushing a small asteroid off its course. The probe's target was the just 160-meter-large Dimorphos, and the impact of the probe was able to push it out of its original orbit by a full 32 minutes. In the case of an emergency, that would be enough to steer a projectile like 2024 YR4 onto a harmless path. That's encouraging for the future, and we will need it, because YR4 will certainly not be the last asteroid to pose a danger to us. The last major asteroid event was in 1908, when an asteroid of a similar size to YR4 exploded over Siberia. The asteroid entered the Earth's atmosphere at an angle, slicing off thousands of square kilometers of forest in seconds and killing countless animals in Siberia. Since the area is sparsely populated, it's likely that no people were harmed at the time. Some residents in nearby villages merely heard a tremendous boom. The event happened more than 100 years ago. Statistically, a smaller asteroid enters the Earth's atmosphere every few years to decades. Most of the time, smaller rocks burn up without a trace. However, experts warn that a larger asteroid could come at any time, and it's not always certain that we will be able to see it years or decades before an impact. It depends on the asteroid. Very dark asteroids can escape our telescopes. This was frighteningly demonstrated by the approximately 1,000-meter large object Oumuamua, which almost passed the Earth undetected a few years ago. Oumuamua was unusually dark and only caught the attention of astronomers when it was already passing the Earth and heading towards the Sun. If this object had been heading for Earth, it would have appeared at very short notice. NASA needs several years to build a probe like DART, and we can't just send any old probe either. The impact force has to be precisely matched to the asteroid, otherwise it could be pushed too far or not enough. NASA also has to rule out the possibility that a deliberate collision with a probe could split or fragment the asteroid. If that were to happen, we would have to deal with several dangers at once. A fragmented asteroid could release several fragments into Earth's oceans, which could lead to an incredible mass tsunami. If fragments hit the Earth, the scenario would not be much better either. Imagine we have 5 or 10 events similar to that of the Chelyabinsk asteroid or the asteroid of 1908. That would be like a massive asteroid rain. How endangered are we on Earth? Have you ever wondered how safe or unsafe the situation is statistically? Some sources say that it is only a matter of time before a large asteroid appears on our cosmic doorstep. Calculations are difficult, and we know very little about asteroid events in the past. Nevertheless, experts estimate that the risk of a regionally destructive impact is around 0.1% per year, which means that an event like Tunguska could occur about once every 500 to 1,000 years. The risk of a global catastrophe that could drastically change life on Earth is estimated to be around 0.000001% per year, meaning that an asteroid several kilometers in diameter is only expected to hit Earth once every 1 to 2 million years. A catastrophic event like the Chicxulub asteroid, which wiped out the dinosaurs 66 million years ago, will hit us in the next 100 years with a probability of less than 0.000001%. But despite these seemingly low probabilities, surprises like Oumuamua cannot be ruled out. The interstellar body suddenly appeared in our solar system in 2017 without us having noticed it before. Smaller asteroids, such as the Chelyabinsk meteorite of 2013, also show that there are still gaps in our surveillance. This 20-meter wide rock was only discovered after it had entered the atmosphere and exploded over Russia. Had it been a bit larger, or had it fallen over a densely populated city, it could have been a disaster. But what has been done worldwide in terms of asteroid defense? It's not only NASA's job to take care of planetary security. The ESA and other space agencies are also actively involved in asteroid research and the development of possible defense strategies. A significant milestone was NASA's DART mission, which successfully rammed the asteroid moon Dimorphos in 2022, changing its orbit, a crucial demonstration that we can actually redirect asteroids. The European Hera mission will study the impact of this change in orbit and thus provide valuable data for future deflection efforts. Japan is also at the forefront with its Hayabusa missions. In 2010, the Hayabusa probe brought samples of an asteroid to Earth for the first time. Hayabusa 2 followed suit in 2020, bringing valuable samples of material from the asteroid Ryugu. China is planning a mission with Tianwen-2 to Kamaluala, a small near-Earth asteroid, while Russia is exploring various concepts for using nuclear warheads to deflect asteroids. In the event of an emergency, each nation would contribute the best of its science and engineering. Even if the asteroid were to only hit a particular country, the United Nations has decided on joint plans and financing models. The responsibility could and should never lie solely with the nations that would be unlucky enough to have an asteroid fall on them. But what might an effective defense look like in practice? One possibility is to push an asteroid off its course using a kinetic impactor like DART. If the impact time of an asteroid is known well in advance, a so-called gravitational tractor could be used. This spacecraft-based asteroid defense vehicle would remain in stable proximity to an asteroid and would influence it over years with minimal but constant gravity. This could be enough to slowly displace an asteroid, and the probe could accompany the rock and thus repeatedly make necessary course corrections. In particularly urgent cases, the most controversial option would remain, and probably only that. A nuclear explosion or targeted vaporization of an asteroid is a risk. If debris remains or the dissolution is not complete, debris could still hit Earth. Click the subscribe button now. The best videos are yet to come.